Good morning. Today, what I'd like to do is to set up a sample homework for numerical analysis, show you in an informal, rambly way how you do this sort of thing, but then, more importantly, show what a good format would be in order to hand the homework in. Firstly, I'll need a sample problem. For my data set, I'll have 3 points. The indexes on the data points will go from 0 to 2, and my data points themselves will be 1, 3, 2, 5, and 4, 45. As we have discussed previously, the function values are actually polynomials of degree 0 that interpolate the data set at single individual x values. Continuing to use the temporary notation that we have before, I can write down the first column in the table that I'm going to calculate. P0 is the constant polynomial 3, P1 is 5, P2 is 45. Using our R recursion formula, we'll get P01 and P12. Then after that, we'll combine those two expressions to get P... Blah. I said I was going to leave all of my rambling in, so I just made an obvious mistake. We will combine that and that to get P012. I'll pause this. I have to make another cup of coffee. You may hear a humming noise in the background. That's because my space heater is going. In a moment, you'll hear coffee making sounds too. I feel that this gives more authenticity to the mathematical experience here. Anyway, we want to calculate P01. Ordinarily, this is the part you never let anybody see, where you're fumbling around calculating stuff. P01 is x minus x0 times P1 minus x1 times P0 divided by x1 minus x0. There's the coffee. X minus x0, that would be x minus 1. I'm going to multiply that by P1, which is 5, minus x number 1 is 2. I'm going to multiply that by P number 0, which is 3, divided by x1 minus x0, which would be 2 minus 1. The denominator is 1, which is extremely convenient. The numerator is 5x minus 5 minus 3x minus 6. 5x minus 3x is 2x, and negative 5 minus negative 6 is plus 1. Sanity check here. If x is equal to 1, the value of this polynomial is 2 times 1 plus 1, which is 3, as it's supposed to be. Also, if x is 2, 2 times 2 is 4, plus 1 is 5, just like it's supposed to be. One down, 2 to go. In a likewise way, I'm going to have to figure out what P12 is. We'll follow the same pattern, though. This is x minus x number smallest index out of the bunch is 1 this time, times P2 minus x2 times P1 divided by x2 minus x1. x1 is equal to 2. P2 is equal to 45. I'll have to subtract away x minus x2, x minus 4, times P number 1, which is 5. Then divide by x2 minus x1, that would be 4 minus 2. And all I have to do is simplify the algebra. So this will be 45x minus 90, and from that, I'm going to subtract away whatever x minus 4 times 5 is. 5x minus 20 over 2. 45x minus 5x is 40 times x. Negative 90 minus minus is plus 20 minus 70 divided by 2, which will be 20x minus 35. Allegedly, this interpolates my data set at the place where x is equal to 2 and y. Allegedly, blah, 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 blah. Allegedly, this interpolates my data set at the place where x equals 2 and x equals 4, producing function values of 5 and 45 respectively. I'll be extremely lazy here. If x is 2, I'm going to have 2 times 20 minus 35, and I get 5 for an answer, just as I should. If x is equal to 4, I'll have 20 times 4 minus 35, and I get a 45 for an answer, just as I should. So this is correct. I want to emphasize once again, all of this stuff about misstatements and writing stuff down in this sloppy, horrible way, you never let anybody see this in the final thing that you hand in. Next, we will figure out what P012 is by doing the same sort of procedure to these two polynomials. So P012 is x minus the smallest index in the mix right now, which is 0, times the p polynomial that goes with the bigger indexes minus x minus the biggest indexed x times the p polynomial that goes with the smaller indexes divided by biggest indexed x minus smallest indexed x. X minus x0 is x minus 1. P1, 2 worked out to be 20x minus 35. Then from that I have to subtract x minus. X number 2 is 4. And I have to multiply by the polynomial that goes with the smaller of the two indexes, which worked out to be 2x plus 1. Divided by x2 minus x0, that would be 4 minus 1. Just as before, I have to simplify this, but this time it's going to be a little bit messier because of linear times linear instead of linear times a number. Linear times a number, see. Bottom of the fractions going to be 3. Upstairs, x times 20x minus 35x minus 20x minus minus is plus 35. And then I have to subtract away whatever x minus 4 times 2x plus 1 is. X times 2x is 2x squared plus x times 1 minus 4 times 2x minus 8x minus 4 times plus 1 minus 4. I can go ahead and simplify this a little bit before I get rid of the grouping symbols. 20x squared minus 55x plus 35 minus 2x squared minus 7x minus 4 divided by 3. I'm being careful about my grouping symbols and that negative sign. 20x squared minus 55x plus 35 minus 2x squared minus minus is plus 7x minus minus 4 is plus 4 over 3. $20x squared minus 2x squared, 18x squared. I'm subtracting 55x away and adding 7. It's early in the morning. 7 minus 55 is negative 48. Minus 48x. And then plus 35 plus 4 is 39. And I have to take that and divide it by 3. It'll be 6x squared. 48 divided by 3 is 16 minus 16x. 39 divided by 3 is 13. Allegedly, this is the polynomial that's going to interpolate at all three of my x values, the x equal 1, x equal 2, and x equal 4 values. So let's see. I'll store 1 into the x variable, calculate 6x squared minus 16x plus 13, and get 3, as I should. When I put the 2 in, I'm supposed to get a 5. Hey, Nick. And I get a 5. When I put the 4 in, I'm supposed to get 45. And I get a 45. This verifies that my answer is right. This is the interpolating polynomial of degree 2 or less that interpolates my data set. But that's not the important part. What I'm really up to here is to show what a good form would be to hand in homework of this nature. We already talked a little bit about this when programming is involved. There's no program right now. There's just a bunch of mathematical formulas. What to do, what to do. Add. Screen capture. Yeah, didn't like that. Try that again. Tried the pipewire screen capture deal. Didn't like it. Let me try the XSHM one. Ah, there we go. If you're on Windows, there must be some nice, well, maybe not. There must be some nice documentation preparation software that you can use. What I'm using is LaTeX with a graphical user interface on top of it. So that's what I'm going to use to write my little document here. So, new. I'll give this thing a title. Oh, just a second, please. Yes, ma'am.
Sorry. Out of curiosity, do you teach linear math?
Linear algebra?
Yeah, linear algebra.
Well, I have a few times. I don't think I taught it this last time, though, but I have.
Okay. Are you going to be teaching linear math or discrete mathematics in the future?
Well, probably discrete. Don't know about linear. There was some uncertainty about who was going to pick that up when Dr. Sahi let go of it.
Okay.
So my answer is a definite maybe.
That's all I had. Thank you.
Okay. So So let's see, title. And put a little space in. One thing about this software, it gives you a lot of control about how things are going to be formatted. In fact, it gives you total and complete control over it, which is good or bad depending on your point of view. My point of view is it's good. So I'm going to pretend that somebody gave me this as a homework assignment and that this was problem number 1. Let's see. Ooh. Caps lock. Obviously need more coffee. Let's see, what's the data set? One, 3, 2, 5, 4, 45. See about using a matrix environment for this. So let's see. I'm looking at my pieces of paper here. I need to have 3 rows and 3 columns. Well, how about I do 6 rows and 6 columns, because that will allow me to put blank spaces between things. Maybe it'll look a little bit nicer. alignment. Just leave it as is. Okay, up here I'm going to have P subscript 0, which is equal to 3. Skip a line. P subscript 1 equals 5. Skip a line. P subscript 2 is 45. Now, at the moment, I don't know any of the rest of these things. So on this line, I'm going to have P sub 01. I'll type that in a minute. I'll have P sub 12. I'll type that in a minute too. And I'll make a little more space there. I'll put P sub 012 there. There is the issue of how much algebra I want to show. I could show all of it, or I could just say, here's the setup. After I did the algebra, I got this result, and I know that it's right because everyone knows how to finish the sentence. Insert math. We'll put at least a couple of lines in here. So I will use the equation array environment. P sub 01 equals, we're going to have ourselves a fraction. It's going to be x minus x0 P1 minus x minus x1 P0 divided by x1 minus x0. Control Enter gives me another line. Equals fraction upstairs x minus 1 times P1, which is 5, minus x minus x1 is x minus 2 times P0, which is 3, divided by, on the bottom, x1 minus x0 is 2 minus 1. Control Enter gave me a another line. We figured out that this is 2x plus 1. And I'll say something like, firstly, let me make sure that all this stuff is going to be understandable by my document system. Let me have a look at this. In this problem, we're supposed to find the interpolating polynomial of lowest possible degree for the data set, blah, blah, blah. To do this, we will look at the same sort of recursion that we've talked about in class. To be exact, the function values are polynomials of degree 0 that interpolate at single data points. We will set up a table of the following form. P0 is 3, P1 is 5, P2 is 45, and we have to figure this and this and this out. Doing the recursion, P01, x minus x0 P1 minus x minus x1 P0 divided by x1 minus x2, which allegedly, after you get done doing the algebra, simplifies down to 2x plus 1. Sanity check again. When x is 1, that'll be 3, and when x is 2, it will be 5. I'm being a little bit lazy there. I should probably have shown the evaluation, but I'm going to assume we can all do college algebra, so that's really not an issue. I have to go off to my Calc 2 class in a moment, so I'm going to pause the recording, and when I get back, we will pick this back up. Pausing in 3, 2, 1, pause. Now here, I'm going to be intensely lazy. Except it's not P01 that I'm calculating now, it's P12. Let me annoyingly move the microphone since it's covering up my my calculations here. So x minus 2 times 45 minus x minus 4 times 5, which eventually worked out to be 20 times x minus 35. Oh, one thing that's worth mentioning, never bluff, never say, I checked this and it worked for the two x values that it's supposed to, when in fact it didn't. That would be really bad. Yeah, I guess I should have a period there. Put in a little vertical space. Make it a little more readable. Speaking of readable, let's make sure everything's on the up and up here. Okay. I'll let the spell checker get it for me. P012 x minus x0 times P12, the bigger indexes, minus x minus x0 P0 1, the smaller indexes, upstairs x minus 1 times something. So that's still good. X minus 1 times 20x minus 35. Minus, upstairs it was x minus 4 times P01 was the 2x plus 1 quantity. Bottom of the fraction is 4 minus 1. And the final result was 6x squared minus 16x plus 13. So now, two things. One, I know for a fact I misspelled pattern, so go back up to the top. So this tells me I'm up at the top. Spell checker. Didn't find anything. PDF LaTeX. So let's see here. Give it a read through. We are to find the interpolating polynomial of the lowest possible degree that interpolates the indicated data set. To do this, we'll look at the same chord of recursion, blah, blah, blah. Okay, x minus x0 p1, x minus x1 p0, x1 minus x0, when x is 1, that's 3. When x is 2, that's 5. It's easy to check that. P12 is x minus x1 p2 minus x minus x2 p1 over error. Got myself a mistake right there. In the second one, I didn't change these indexes from 1 and 0 to 2 and 1. So I got to go in and fix that. It's the second one. X minus x1 is x minus 2. X minus x2 is x minus 4. That's correct. P2 is 45, and P1 is 5. Bottom of the fraction should be x2 minus x1. That would be 4 minus 2, so I didn't change that one either. See, this is why you have to be careful about cutting and pasting, because you'll do stuff like that. Same deal here on the bottom of the fraction, because copy and paste. X minus x0 P12 minus x minus x0. I'm going to need to go back and double check that. X minus x0 P12 minus x minus x2 P01 x minus 1 x minus 4 P12 is 20x minus 35. P01 is the 2x plus 1. And on the bottom of the fraction, and x2 minus x0 is 4 minus 1. Okay. Let me go back and look at that first one. P01, x minus x0 P1 minus x minus x1 P0, x1 minus x0, x minus x0 is x minus 1, x minus x1 is x minus 2, P1 is 5, and P0 is 3. Okay, so that's all right now. Oh, I don't think I put any new words in. It never hurts to check. Now, this is the LYX file. If I want something that I can print out or email to somebody, I'll view this as a PDF file one last time, except I'll go over here and say save as. Going to put it in documents. It's going to be called sample.pdf. So then I'll get rid of all this stuff. With any luck, everything will have gone right. Let's see, documents. There is sample.pdf. There we go. So then I could print the PDF out, or I could email it to somebody. I've got a really nice looking document here, complete with formulas and numbers and stuff. This is the kind of output that we want to aim at. I'm thinking, do I want to say anything else here? I'm thinking no. In any case, hopefully this has been of some help. I'll talk to you again soon.